In this screencast, we're going to talk about flux, which is the flow across a curve. First, we'll start with two vector fields, an outward pointing radial field and an inward pointing radial field. With this vector field right here, if I were to take some curve and go around a curve, then the question is, does this field cause fluid? If you think of the vectors as fluid flow, are those things flowing out or into the circle? And in this case, they're flowing outward. Hence, we say the flux is positive. In this picture, the vectors are all flowing inward. So if I take some curve and try and ask, is fluid flowing into or out of the curve, then here I can say the flux is negative. Things are flowing in, and we call that negative flux. Flux is a measure of how fluid is flowing in or out of a curve. Just a picture from Mathematica briefly. In this case, we've got this vector field which is causing some kind of spinning or radial outward. It's not radial, it's an outward flow, and it's kind of spiraling some. Think of it as a tornado spinning things around. And if we move along this curve, these vectors pointing out are the normal vectors to that curve, then we can tell that the vectors are flowing in, they're flowing out of the curve, and so we see here we have positive flux. We'll return to this example before we're done. To explain where flux comes from, we have to return to work. Work was F dot T ds, or we also wrote it as m dx plus n dy. The idea is this quantity right here, f dot t, computes the amount of the vector field in the direction of t. If I've got a vector field and I have a curve run along that vector field, and I'm moving along a curve, and I want to know how much of the vector field is in the direction of the curve, I can take this vector and ask how much of it moves in the direction of t. This is f dot t. It's the amount of the vector field, the amount of flow in the direction of the field. Well, if I want to know how much of the vector field points out, that's this vector, and this is f dot n, where n is a unit normal vector pointing out. That provides us exactly with what we need for flux. Flux is written sometimes with a capital phi. It's an integral. It's always along a closed curve, and it's f dot n ds. The only difference is rather than using a tangent vector, we use the normal vector, and this normal vector needs to be outward pointing. Well, to get that outward pointing vector, a formula we're going to be using is we're going to integrate m dy minus n dx. How does it differ from this one? You can think of this one as mn dot with dx dy. And if you flip the order, so here I have an mn dot with, change the order, dy dx, and then change the sign on the dx. This is your normal vector times a little bit of length. This is the tangent vector times a little bit of length. Why is that true? Well, if you're going along a curve, and let's pick a spot on the curve where, suppose you go over 1 up 2. So our vector, our tangent vector is 1, 2. Well, if I want the normal vector would require that I go over 2, down 1. So if that's t, then the normal vector would be over 2, down 1. Notice that I took the dx, dy, flopped the order, dy, dx, and put a negative sign on the x term. That's why we have a negative here. To get the vector going out, you always put a negative on the right term. If you want the vector going in, you put the negative on the left term. Well, that gives us our formula. Let's now just do this. Let's actually use it to find the flux across a certain curve. Let's take a different vector field. The vector field we're going to use is now x plus y, comma, y. And we need a curve, so let's take as our curve a circle of radius 2. So t is going to go from 0 to 2 pi. Well, to do that, I need to get r prime, which is negative 2 sine t, 2 cosine t. And now I just need to start noticing things. This is x. This quantity is y. This quantity is our change in x. This is our change in y. So if I want to use this formula down here, we've got to get an m and an n. So we take m, which is x plus y. We need our dy, which is 2 cosine t. I need a minus n, which is y, times dx, which is negative 2 sine t. Integrate that from 0 to 2 pi with respect to t. And since it's a t, I better make sure I replace all my x's and y's with what they are in terms of t. Here's my x and y. So I've got a 2 cosine t plus a 2 sine t. Now I just copy this down. 2 cosine t minus y is 2 sine t minus 2 sine t dt. Integrate from 0 to 2 pi. I'll let you finish that integral. It's one you can do. That completes the screencast.